Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human Centric AI podcast, where each episode we interview thought leaders doing cutting edge work in the AI space. A little bit about us. SmartEye was founded over 20 years ago, and we have been known for developing some of the world's most sophisticated eye tracking systems. In recent years, we've expanded our technology and are now known as the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments. We are bridging the gap between humans and machines for a safe and sustainable future. Our multimodal software and hardware solutions provide unprecedented human insight in automotive and behavioral research, supported also by Affectiva and iMotions, companies we acquired in 2021. In automotive, we are leading the way towards safer and human-centric mobility through driver monitoring systems and interior sensing solutions. Our tech is embedded in next-generation vehicles and available as a standalone aftermarket solution for existing vehicles, fleet, and small-volume OEMs. Today's episode features Baman Haji, Director of Product Management, Automotive Sensing Division at onsemi. Baman has over 15 years of experience working with image sensors in the medical, consumer, and automotive markets. In his role in the Automotive Sensing Division of onsemi's Intelligent Sensing Group, he manages a global team focused on driving the product roadmap strategy and bringing to market high-performance automotive image sensors using ADAS, autonomous driving, in-cabin, and LiDAR applications. Prior to joining onsemi in 2017, he held product engineering and product marketing roles at Aptina Imaging and OmniVision Technologies. Baman obtained both his Bachelor of Applied Science in Computer Engineering and a Master of Applied Science in Electrical and Computer Engineering degrees from the University of Waterloo in Canada. onsemi is driving disruptive innovations to build a better future. With a focus on automotive and industrial end markets, the company is accelerating change in megatrends such as vehicle electrification and safety, sustainable energy grids, industrial automation, and 5G and cloud infrastructure. With a highly differentiated and innovative product portfolio, onsemi creates intelligent power and sensing technologies that solve the world's most complex challenges and leads the way in creating a safer, cleaner, and smarter world. onsemi operates a responsive, reliable supply chain and quality programs and robust ESG programs. Headquartered in Scottsdale, Arizona, the company has a global network of manufacturing facilities, sales and marketing offices, and engineering centers in its key markets. I invited Baman to talk today about depth sensing and its importance, applications for adaptive restraint systems, user interaction security features, and future protocols and industry standards. So let's listen in to learn more. Okay. Hi, everyone. Thanks for tuning in. With me today, I have Baman Haji, Director of Product Management, Automotive Sensing Division at onsemi. Baman, thank you so much for making the time to speak with me today.
Great to be here. Thank you, Ashley, for having me on.
Absolutely. So to start, tell us about your background. How has your career path taken you to onsemi, and what is your current role there?
Yeah, so happy to talk about that a little bit. For my whole career, worked on sensors or sensing devices. So I did my undergraduate and master's degrees in engineering and electrical and computer engineering. And I did my master's in medical imaging, so CMOS image sensors for medical imaging applications. And then I got my first job out of college at Aptina Imaging, working as a product engineer, which led me to get exposed to working in industry for image sensors. Now, at the time, there was a lot of focus on automotive image sensors, but it was really, this is 15 years ago, that was a small but growing segment, but there was a ton of focus on mobile with image sensors for cell phones and smartphones with all of the adoption there. So I worked for a couple of years as a product engineer, and then I switched roles into product marketing and business development. And then I switched to a different company, worked there for a few years. That's when I moved into the automotive sensing space and worked in a couple of different roles, both in business development and product management, dealing with ecosystem partners, algorithm partners like SmartEye, and also SoC partners. And then came back to onsemi almost 8 years ago now. onsemi acquired Aptina and became the number one vendor of image sensors for ADAS and autonomous driving. And that's what I've been doing the last 7 years. We also acquired a company that does LiDAR sensors. So I worked in that division for a few years. But my current role is I'm basically responsible for product marketing, product management of our automotive sensing business line. So the P&L responsibility in the product line for automotive image sensors and LiDAR sensors. It's about a $1 billion annual business. And it's a really, really dynamic and interesting role. I have a team that manages all of the products that's global. And I get to do things like this where we speak about the industry and all the things we're doing to improve safety in vehicles, which is really what we're all here to do.
Excellent. Yes, definitely. So, for those who are unfamiliar with onsemi, can you explain briefly what your offerings are in the automotive space?
Absolutely. So, onsemi's tagline is intelligent technology, better future. And we focus on intelligent power and intelligent sensing solutions. So we have three business groups. We're divided into the power solutions group, the analog mixed signal group, and the intelligent sensing group, which is what I'm a part of in the automotive sensing division. We're focused on automotive and industrial end markets. Industrial includes things like 5G and cloud and other types of end markets. Automotive is, of course, with vehicle electrification and autonomous driving, there's just more and more adoption of semiconductors in vehicles. And so our power solutions group, for example, is a leading provider of silicon carbide and devices that enable electric vehicles to have longer range and more efficiency. And of course, then our analog mixed signal group has power management devices and ASICs and things around the system that control and give the intelligence to the power solutions and to the image sensors. And so then the intelligent sensing group, which I'm a part of, is divided again into our industrial and commercial solutions, where we're in space, military, and industrial warehouse automation applications. And then also automotive, which is ADAS and autonomous driving.
Mhm.
And the largest part of that market is really passenger vehicles, where you started with, this is now, I think, as of 2018, backup cameras became standard. So in the United States, but really the adoption of image sensors and cameras in vehicles goes back 2 decades. And onsemi was the first company to come out with an automotive image sensor back when it was Aptina Imaging, and before that, Micron. So we have the legacy of knowing how to provide into this space. And onsemi is about a $6 billion revenue company, $6 to $8 billion revenue company, and we have about 30,000 employees globally. Our headquarters is in Scottsdale, Arizona. So onsemi, we have a strategy which includes both having fabrication manufacturing facilities in-house, but also externally. So we have a combination depending on the business group, where we use external manufacturing partners, and we also have internal partners, internal manufacturing sites for that.
So, I did have a couple questions for you around depth sensing and its importance. So, first, could you explain how onsemi's depth sensing technologies, such as I think it was indirect time of flight, so ITOF, how that really enhances something like Smart Eye's interior sensing capabilities?
Yeah, absolutely. So what we offer is we have image sensors and a lot of driver monitoring systems and interior sensing solutions use 2D global shutter image sensors. So you're capturing the scene, you have infrared illumination, and then you have an image sensor which captures the reflected infrared light. You have a global shutter image sensor, which means that you're capturing the entire scene at once,
Okay.
so that you don't have to have your infrared illumination on all the time as you're doing a rolling shutter readout. Now, when you do that, you don't have depth capability because you're just capturing the intensity of the reflected light.
Mhm.
What ITOF is, or indirect time of flight, is a way to do depth sensing where you take multiple captures from a modulated wavelength of light. So you send that out, and then you're looking at not just the direct time of flight, but you're taking multiple samples, and based on the phase difference of the reflected light, you're able to compare that and calculate the distance to the object, in addition to getting the intensity of the image like a 2D image sensor would. So with our indirect time of flight depth sensing technology, our smart indirect time of flight depth sensing technology, we're able to provide not just the depth calculation, so a 3D point cloud of the space, but also a 2D intensity image simultaneously. And we can do that because we're taking multiple captures at the same time without having any motion artifacts. So at once you capture the signal multiple times, and then you're able to calculate the depth. Now, what that does in terms of the end application is, if you can think of a driver monitoring or interior sensing situation, you would be able to know precisely how far away something is from the sensor. And what that means is the driver's position, whether it's someone who might be closer to the wheel or someone who might be further back, you're going to be able to discern that. And that can be important for different types of safety applications, like how to deploy the airbag, or when to deploy the airbag if, for example, the driver is too close to the steering wheel, or if the passenger has their feet up on the dash, for example. Those are all things that you're going to have much more precise readings if you have a depth sensor, rather than trying to calculate or indirectly estimate the depth based on a 2D image and human models.
Okay. Very cool. So as I understand it, the depth sensing provides a detailed, 3D view within the cabin. What are the core challenges that onsemi's depth sensors overcome in order to achieve this level of detail and accuracy?
So there are a couple of different problems that this type of imaging situation leads to. One of them is the effect of having the sun come into the cabin. And that creates a very high dynamic range and environment, because you might have shadows and you might have the sun coming in and not be able to see all of the detail. So with the onsemi smart ITOF depth sensing technology, as I mentioned, not only do you get the depth, but you can also actually subtract the sunlight and get an actual intensity image in addition to your amplitude output. So, for example, if you have the sun coming in and it's occluding where the seatbelt is on the driver, you'll actually, with the onsemi smart iToF depth sensing technology, be able to see that the seatbelt is there and the passenger is buckled. And really, the solution here is the automotive OEMs are always looking at how can we improve the technology and the safety of the vehicles, but also how can we save cost.
Mhm.
And what we're able to do is offer a type of technology that can do things so you can start to eliminate some of the more legacy sensors that may exist in the vehicles. For example, for occupancy detection, there might be a weight sensor where the passenger is sitting down, and that's how it knows that the seatbelt needs to be buckled. And then there's a seatbelt buckle sensor, of course. But if you have something in the seat, if you put your bag there, that might go off, and then it might say that you need to actually be buckling your seatbelt. Or those are the types of situations where, if you have a vision system, you're able to actually tell whether there is a passenger there or if it's something else. You can also enable other features that are convenience features. One of them is just being able to detect if something's been left behind. So if
Mhm.
you have a set of keys or something, if you have depth sensing technology, even in the darkest environment, you're able to actually tell if there's something on the seat, because you can tell the difference between for example, the depth of the keys versus where the seat would be.
Cool.
Those are all kind of features that could be implemented with this type of technology. Not to mention other convenience features like driver authentication.
Mhm.
So if you sit down in your vehicle and you press a button so that it changes the position to where you'd like to be, whereas your wife may like the seat to be somewhere else. That's just an example. You'll be able to have that convenience feature as soon as you get into the vehicle. And with having depth sensing, you're able to add authentication to that. So not just being able to spoof it by showing a photo of the driver, but you have to actually know that the person is actually there, which is exactly how authentication works with cell phones, for example, as well. They have to have some sort of 3D depth sensing, if it's whether it's ITOF or structured light or something else.
Okay. Very cool. So you touched on this a little bit with regard to seatbelts. So talking about applications for, adaptive restraint systems. So I would love to talk more about, onsemi's tech. How does it contribute to these types of systems, particularly in supporting those the safety standards like Euro NCAP, and I think it's FMVSS 208. I know those are, everybody's talking about the up and coming implementation of those, and maybe you've already kind of touched on this, but I did want to give you a chance to expand on how this depth sensing improves the accuracy of, the seatbelt, the airbag adjustments for occupants, given the tech's ability to analyze, occupant size, position, and proximity to surfaces. So I don't know if you wanted to expand on what we already talked about, but
Yeah, actually, so it's interesting because there's all of these different regulations and different regions that come into play, and automakers are always trying to make sure that not only are they compliant, but they're looking ahead and future-proofing their vehicles or trying to see where the regulators are going to be. So FMVSS is in the US, the Federal Motor Vehicle Safety Standard, I think is the broad regulation that the Department of Transportation has. This is mandated the backup cameras in the vehicles as of model year 2018, and it's continuing to introduce things that will improve the safety of the vehicles. So distracted driving is one of those things. And what you have in Europe is you have a couple of different standards. There's the governmental regulations, the European Union's general safety regulations. One of the things that they've done is, as of 2024, are saying that new vehicles have to have some sort of driver monitoring system. And what that means is, as you're having distracted driving will lead to a lot of deaths, even as the attach rate for ADAS features like forward collision warning and adaptive cruise control, as the vehicles are becoming smarter and able to help the drivers drive,
Mhm.
drivers are getting, let's say, a little bit more cavalier about paying attention to the road, even though these are really systems that are helping you drive. You're still responsible. So that's why driver monitoring systems are so important, because you're able to detect whether a driver is drowsy or distracted or on their phone and not paying attention to the road. And you can marry these things together by saying, okay, if I know that the driver is distracted, not only am I going to warn the driver to take control if I see that I'm in a forward collision warning situation, or I have to apply the automatic emergency braking of the ADAS system. But you can go a step beyond and say, as these advanced systems that are getting to beyond level 2, they're getting to level 3, where the vehicle can start to drive itself. You still need a driver monitoring system, because in some situations, they need the driver ready to take over.
Mhm.
So even once the vehicles have true self-driving,
Yeah.
there are situations when the driver needs to be able to take over. So you can offer eyes-off driving to the drivers, but if they're sleeping and then you encounter a situation where you say, "Well, I need to hand back over the control to the driver," you need to know that they're ready to take over without
Mhm.
without a safety issue.
Yeah.
And then you also have the new car assessment program. So that's NCAP or Euro NCAP. And that's not so much a governmental regulation, but something that is an industry standard where they rate the vehicles based on a star rating. And they basically give you brownie points or stars for more and more safety features. And ultimately, you can have ADAS features that externally will actuate the vehicle so that it prevents collisions. But interior sensing and driver and occupant monitoring is all about making the cabin of the vehicle contribute to that. And that's not just warning the driver to prevent a collision, but ensuring that, for example, they have their seatbelt on properly, and that when the airbag gets deployed, it's not going to injure the driver because they're too close to the wheel. Those are all situations where you're going to have a contribution from the driver monitoring systems to the safety and meet both those government regulations and the industry standards that cause people to buy safer vehicles.
Excellent. And I did want to talk about, and you mentioned briefly, so some user interaction security features. You talked about driver authentication earlier as being, another use case. I don't know if there was anything addition you wanted to say on how, onsemi can enable this, this reliable identity verification within the vehicle with the depth sensing. But please do let me know. Otherwise, beyond, safety, depth sensing also enables, I believe, dynamic gesture detection for in car interactions. So I was wondering if you could talk a little bit more about that and how that onsemi's sensors enhance these gesture-based controls and what applications would you foresee in future vehicles?
So the first part of your question with respect to driver authentication, one of the things that the onsemi smart and direct time of flight depth sensing technology does is it enables better power efficiency for the depth calculation, which is an important part, as we talked about, of being able to do face authentication, because our depth sensing technology enables the calculation to be done on chip. In other words, you don't need to send frames off chip for that calculation to be done on a host processor or on a separate microcontroller or ASIC. The image sensor itself will be able to output the depth information, which means that the algorithms can just focus on the authentication rather than having to also utilize power for the depth calculation. So that makes the overall system more efficient,
Mhm.
in addition to, of course, providing the functionality to do the authentication. And so that's one of the ways that we contribute further to that. Now, in terms of other applications, of course, once you have a depth sensor, you're able to do a lot of different things with it. If you just go back and think about all of the different interactive devices that use gesture, whether it's laptops, gaming, controllers, this type of situation where you can uh, control a heads-up display or whatever you're looking at, whether it's an interface where instead of having knobs, you're able to actually use your hands and your fingers to go back and forth. Of course, you're able to do that if you have a 2D imager and you're capturing the scene, but being able to have depth allows you to more precisely be able to recognize and capture gestures easily. If you're saying, say, I want to do a button press, it'll be able to tell you if you go like that. Whereas that might be more difficult or computationally intensive to do from a 2D image. So being able to have depth sensing means you can enable gesture features as well for, let's say, a situation where the driver is in a vehicle that is level 3 or level 4 or level 5. So they do not need to be attentive to the road or have their hands on the wheel. And then they can just be looking at their display and watching a movie and scrolling through without having to reach over and touch the display. You could even see situations where this is more futuristic, but when the vehicle switches from level 3 where it is eyes off, but the driver has to be able to take over, to level 4 where it really is able to drive itself and it knows and it'll be able to safely pull over. You could maybe have the steering wheel retract and have a display come down, and now you're able to just control that using your gesture functionality. And you just have to have a camera up here that's capturing the driver and able to, within the field of view, also able to capture all of the gestures. You could even get into gaming, all these things that someone wants to be able to do to turn the vehicle's cockpit into also an infotainment or entertainment kind of an environment. Of course, that all has to be done safely, which means that first we must solve the problem of autonomy, and we can't have this situation where it's level 2 plus and the driver is responsible, but we're giving them all these features that are entertainment but distracting. I think that's one of the biggest challenges of the industry right now.
Mhm. Absolutely. I was thinking as you were talking, I was like, oh, we're driving and we're also playing a game. It's like, yeah, okay, that makes a lot of sense.
Yeah.
So again, looking towards the future and protocols and industry standards, we talked about Euro NCAP, but how is onsemi preparing to address these evolving regulatory and rating system standards, especially as these protocols are demand increasingly sophisticated in-cabin safety solutions?
So we're a provider of semiconductors to our customers who build systems who go into vehicles. So our customers are typically the tier 1 manufacturers that build systems that they then sell to the automotive OEMs. So if you go to a car dealership and you're buying a vehicle from a number of different manufacturers, whether they're European, American, or Asian, what's happening is those companies most of the time are buying those systems from other companies and they assemble the vehicle together. So what we have to do is talk to the OEMs in addition to the tier 1s that are our customers, to be able to uh, tell them about the nuances and the features of how our sensors are able to support their end applications. One of the things that we do with our image sensors is we're able to provide what's called the automotive safety integrity level, or ASIL, features on chip. And what this means is that the image sensor itself, as it's imaging, is always doing a self-test and making sure that you don't have any problems on the chip.
Mhm.
And this is throughout the lifetime of the chip's operation for over a decade and thousands of hours of life. It's always going to be testing itself. And what that means is if there is an issue, the detectability of it is very important. So we can tell our tier 1 manufacturers, here is a safety manual and how we want you to implement the image sensor so that if there is an issue, it'll be able to flag that, because that's really important in an automotive environment where safety is critical, that if there is an issue, you flag it and you detect it, and you can mitigate the risk at that point. Because the last thing you want is to be in a situation where there is an issue that was not found, and that ends up causing the system to make a mistake when it thought that it had reliable data coming out. There are other standards as well, in addition to ISO 26262, which governs automotive safety integrity level, that are coming out for the emerging need for cybersecurity in image sensors. And we were one of the first companies to implement this feature on our sensors, which enables basically for the system to know that the data that's coming from the image sensor is coming from that part and not being spoofed by a man-in-the-middle attack or something where they'll be able to send data and say that it's coming from the vision system. Because ultimately, the sensors externally are the eyes of the vehicle. Right. And cybersecurity is important as a result of that. If somebody was able to send data and spoof it, that would be able to fool the system into doing something that you wouldn't want, and it could lead to a malicious actor situation.
Mhm. Absolutely. So my last question is around technical synergies with Smart Eye. So I wanted to talk or get your take on how onsemi's depth sensor tech How does it integrate with Smart Eye's interior sensing software? Are there specific kind of integration aspects that have been really essential to achieving this seamless user experience that we envision for the future?
Yeah, we've been working with Smart Eye for a number of years, as Smart Eye being one of the leading providers of interior sensing and driver monitoring algorithms. Of course, we provide the image sensors and the hardware, and Smart Eye is able to take that output and run their algorithms on it, and then implement those features at the tier one and OEM level. And the synergies that we have, we've actually shown at multiple trade shows now with respect to our depth sensing technology and Smart Eyes software running on it. We demoed this at multiple shows over the past year, including CES in Las Vegas in January, and most recently at the AutoSense conference in Europe and in Barcelona back in October. And what we showed there is that when you take the indirect time of flight depth sensing technology from onsemi and you can enable it in a driver monitoring camera module, you can integrate it into a small form factor so it still fits into a system in a car cabin, for example, where it would sit under the rear view mirror. And you're able to detect the driver's gaze and where the driver is looking, but also Smart Eye implemented multiple features that use the depth. For example, you can in that demo lean forward, and as you get closer to the camera, it'll show that that would be a situation where you disable the airbag, and it'll show that on the screen. And the other thing that Smart Eye did with that software that really shows you the advantage of having 3D depth sensing is they're always with you guys are always with your software doing a depth estimation, even based on the 2D image sensors that you would use. But in this demo, to show the value of this to our mutual customers, you're showing both the 2D calculation of the depth, the estimate, and then the 3D actual depth calculation, and showing that error difference, which can sometimes mean the difference between life and death in a safety critical situation like airbag deployment. So I think overall, with respect to Smart Eyes end markets and customers that you're targeting, there's very, very good synergy, and our teams work really well together, both on a technical and business development standpoint, which is why we've been able to, over multiple shows over the past year, showcase this technology together to show that it's not just PowerPoint or some sort of announcement that doesn't have actual hardware and software behind it that customers can start to design in.
Fabulous. Well, that is all I have for you, Bauman. It was a pleasure speaking with you. And thank you once again for having this really fascinating conversation with me today. It's really exciting to kind of talk through all of the technical details and what we have planned together for the future.
Absolutely. Thank you so much, Ashley, and look forward to working with you and the Smart Eye team more in the coming months and years on our joint cooperation. Thank you.
I found this conversation super informative, especially in terms of really understanding depth sensing and how valuable it is to understanding what is going on inside of our vehicles. Smart Eye is really excited to have this collaboration with onsemi, and we are looking forward to all the innovative applications our technologies can achieve together. I hope you enjoyed today's episode. Don't forget to subscribe to our Human-Centric AI podcast on iTunes, Google Play, Spotify, wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on X, Facebook, LinkedIn, and Instagram to share any feedback you have on the show. And don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.